Welcome to our playlist of Gate Questions of Theory of Computation. So our question is, if P, Q and R are three languages, if P and R are regular and if P, Q equal to R, then options A, Q has to be regular, option B, Q cannot be regular, option C, Q need to be regular, option D, Q has to be CFL, context free language. Explanation of options are given. Q has to be regular. This statement is not necessarily true. While it is possible for Q to be regular in some cases, it's not a guarantee. Regular language are closed under concatenation, which means that if P and R are irregular and PQ equal to R, then R is regular even if Q is not. Therefore, Q does not have to be regular. Q cannot be regular. This statement is also not necessarily true. There is no restriction on Q that would prevent it from being regular. It's possible for Q to be regular if P and R are regular and PQ equal to R. However, it is also possible for Q to be non-regular. Option C is Q need to be regular. This statement is incorrect. While it's possible for Q to be regular in some cases, it's not a requirement. There is no inherent need for Q to be regular just because P and R are regular and PQ equal to R. Option D, Q has to be a CFL context-free language. This statement is also not necessarily true, where while it's true that if P and R are regular and PQ equal to R, then Q is a context-free language. It does not mean that Q has to be CFL. There are cases where Q could be regular language, a CFL or even a non-context-free language. So the correct option is, so therefore none of the provided options are entirely accurate. The correct answer would be, there is no definite conclusion about the regularity of the class of language Q. It could be regular, CFL or even non-contextual depending on the specific language P, Q and R. So thank you for watching this video.